Hello, my name is Ian Smith and today's date is the 19th of March 2026. It's 4:34 p.m. UK time, and this is my presentation for the NOCN Construction Management Level 4 qualification and the last unit. This is my presentation for the restaurant project. This presentation has been prepared for the construction team prior to the commencement of our new restaurant project. We will focus through this presentation on the project as a whole and we will focus on a 10-week section of the project, including the foundations, drainage and groundworks. I'm hoping to outline how effective planning and resource management will ensure that the project is delivered safely, efficiently and in compliance with all regulations. We'll cover three key areas: planning and organising a new construction project, which will include different sources of information, external and locality factors, resources required, storage on site, safety and welfare, management of waste and security. Section 2 will highlight why project planning is important, how creating a construction programme or operational plan will help, what key reportable activities there are, different project risks and opportunities, and communication. This will be complemented by section 3, which is related to monitoring and progress, which will discuss how progress can be monitored and how progress is recorded and reported to different key stakeholders. Let's start with our first section, planning and organising a new construction site project. Different sources of information required. To plan and organise a construction project effectively, I've used multiple key sources of technical and management information. Each source contributes different but complementary details, and together they will allow accurate planning, coordination and risk reduction in line with UK construction requirements such as building regulations and also thinking about health and safety under CDM 2015. As you can see on the screen, the first key source is the construction drawings, including things like sections, details, floor plans, and elevations. These different types of drawings will outline services, dimensions, layouts, levels, and interfaces between different building elements. They are significant because they establish what is physically being built and enable accurate setting out, sequencing of trades to avoid clashes. But drawings alone do not define the performance or installation standards, so we must interpret these alongside other pieces of information. For example, specifications. The specifications describe the materials, the workmanships, the standards, the tolerances, and the compliance requirements, particularly in regards to things such as fire performance, which is integral in a commercial restaurant project such as this. The importance is that they help to translate design intent into measurable quality criteria that can then be inspected and verified by a supervisor such as myself. When we compare the drawings and the specifications together, they provide deeper technical information and control and are critical for meeting building regulations and for warranty requirements when it comes to the handover stage of the project. The third source of information that we could use are the schedules. So the schedules provide the exact amount and detail. They work in line with the specifications to highlight where these different components are going to be installed within the project. They help us to plan things such as procurement and compatibility assurance, ensuring that the correct products are ordered, the correct amount of products are ordered as well, and delivered and installed according to the plans, the drawings, as we can see, but also in accordance with the specifications. To complement these even further, we have our digital model, such as our BIM model. This integrates the specifications, the quantities, the drawings into a coordinated digital environment. It allows us to see things such as clash detection. It allows us to visualize these construction stages, as we can see in this image, and helps us to provide accurate quantity takeoffs. So compare it with traditional drawings, like we can see on their screen. BIM drawings provide a higher level of coordination and help to reduce errors before construction begins, and will support me as a construction supervisor to ensure that the finished product is as it should be. They can also help with CDM regulations, as we can identify design risks earlier on. A fifth source of information on a project such as this would be the construction program, depicted here as the. So this helps us to define the sequencing and the durations across our project. So this is the Gantt chart for the entire project, and we have the 10 weeks located here in this section for the groundworks, foundations and drainage. There's a separate Gantt chart that highlights this 10-week breakdown that we will look at later on in the presentation. So without this Gantt chart, we wouldn't be able to coordinate labour, plant, materials, waste removal, and it would be impossible to prevent clashes and delays. So compare this with our progress against this plan, making it essential for our management control. Yeah, as we were saying, it makes it essential for management control and stakeholder reporting. The last piece of information that we're going to look at is our cost plan and project costings. This is an example of the project costings for the foundations, excavation and drainage and groundworks of the project, those 10 weeks. Their significance is mainly in financial control, and they ensure that I can allocate resources properly and efficiently, and the project remains on budget, which is always a massive consideration in construction projects. Cost information will also influence our different construction methods and procurement strategies for different materials, meaning that this cost information directly affects our planning decisions and the optimization of our resources. So we've considered some different types of information, and each source provides different levels of details. Drawings help to define our form, specifications define our standards, schedules define our quantity of products and location, programs help to define the time of the project overall, our costings define our resources, and our BIM integrates all of these into one digital model to allow us to interact with these in real time. Using sources such as these altogether will enable me to make informed decisions and making accurate planning in line with regulatory compliance, which are essential to delivering the project safely and efficiently and within our time frame. The next point we're going to look at is external and locality factors. So when planning this project, several external and locality factors have been taken into account using the site-specific information. These factors have directly influenced their site layout, things such as their safety controls and their safety considerations, which we will look at later on in the project. The first factor is their site access. We can see that the site is accessed by a major A road to the north, and on the west we have a smaller B road. So this needs to be taken into account when we're thinking about transport routes, disrupting traffic, gaining permissions from councils to close the roads, from the local council to close the road, for example. The fact that it's serviced by good A roads means that it won't be an issue when it comes to delivering materials. However, we will need to have proper traffic management in place in order to prevent any types of traffic incidents at this junction. Other areas that we can consider are some domestic problems. So we have domestic properties here and here behind the project. This is another commercial build, so there's not a domestic project here, but then we do have another domestic estate here. So with that in account, we have to be sensitive with our neighbours. So we need to monitor our construction activities, and specifically things like noise, dust and plant movement and how it could affect the public. So our site layout, as we'll see later, has been designed in such a way to remove risk or higher risk pieces of machinery and storage as far away from residential properties as possible, and our site security and things like our dust and noise suppression and their working practices are going to be controlled in order to reduce the impact on our domestic neighbours. Another thing to consider is the location of a primary school here, and with this area making up the primary school playing fields. So again, this will come into account when we think about site security, which we'll highlight later on in the presentation, but trying to reduce dust and noise to the hours of to the school hours for the primary school, and avoiding delivering materials and things like that during the school run times is another way that we can take these external factors into account. When it comes to the site itself, some of our surveys have identified there's potential contamination in parts of the site, and so this could potentially affect our foundation depths and excavation methods and material and storage locations, and so requires specific handling and disposal of excavated material to prevent environmental harm. Another factor to consider when it comes to external locality factors is the location of overhead services and buried underground utilities. Information from the utility boards have highlighted that the water main for these domestic properties actually runs through our site, but not in an excavation area. So that's something that we have to consider and has been marked on our site plans. But before any digging takes place, appropriate scanning with CAT scans will be completed to ensure that these are taken into account. Overall, evaluating these different locality factors allows the sites to be organised safely and efficiently, and reduces risks to the public and workforce as much as possible, and prevents delays or any type of regulatory breaches. Let's move on to talk about some of the resources required throughout this project. So to deliver this project safely and efficiently, we have key labour, plant and material resources have been identified, timed and located according to the construction sequence. So evaluating when and where each resource is required ensures that our programme can be achieved without congestion, delays or safety risks. The first critical resource is groundworks, labour and excavation plant, as we can see here and here. Including excavator operators, ground workers and a 13-ton excavator and dumper. These are required early on during the early project phase for site clearance, drainage and foundations, located somewhere here in our construction plan. They must be located within the designated excavation zone when they are securely stored, as we will see when we come to our site plan, to allow the safe digging and soil removal. This resource is justified because all subsequent construction activities following on from this depend on properly completed foundations, making it a key part of the critical path. The second resource is our concrete and reinforcement materials, as we can see illustrated here. These materials are required immediately after excavation and formwork, which will fall somewhere in the week 5 to 7 period. They must be delivered just in time and placed close to the pour location to minimise manual handling and avoid double handling on site. Their significance again is structural, and they create the load-bearing base of the building. So correct timing, placement and installation are essential to maintain programme continuity and quality compliance. Again, forming part of that critical path, because if these are not laid correctly, then the superstructure cannot be completed to the correct standard. After these have been completed, the third resource is our structural erection labour and lifting plant, including things like we can see here, our ladders, mupes, things of that nature. So these are required after the substructure has been completed and has been appropriately cured. And it's start when these are required in the superstructure phase is begun. Again, the lifting plant must be stored and positioned in the central lifting zones and must be stored in the plant zones to ensure safety. And this resource is justified because safe lifting capability is essential for installing heavy components such as roofs and solar panels and preventing manual handling risks or delays. The last material, or we are going to look at, or the last two, sorry, are our building envelope materials such as blockwork, timber, cladding, or as we can see here, SIPS panels, which is what this restaurant is specified to be constructed out of. As we're using SIPS panels, these can be delivered to site and erected quickly and will form the envelope of the building. Any that need to be stored will be stored in the appropriate material storage area and will be protected from weather and damage to ensure the quality. Once the weather-tight envelope of the building has been completed, this is another key milestone and allows our internal trades such as electricians, electrical labour, our electrical components, plumbing, plastering, decorating to be continued and to be finished. Some of the key resources required in these areas will be things such as podium steps, mobile towers, to ensure that these are completed to a high quality and to a good standard and safely. But these are only required once the building is enclosed and the first fixed installation begins. They must operate within the internal work areas, coordinated by the floor area to prevent trade clashes and to prevent health and safety risks. This resource is clearly justified because service installation is essential before finishes and commissioning, and it directly affects the completion. Overall, when we align our labour, our plant and our materials within our construction stages of a Gantt chart and site locations, it ensures an efficient workflow and reduces handling and congestion and supports safe delivery of our project. Storage on site. Safe storage on site are essential for maintaining a safe, organised and efficient construction site. Poor storage practices can lead to accidents, material damage, environmental hazards and theft. Therefore, our storage zones must be planned in advance and clearly identified on the site layout, as you can see on the slide. And this will ensure materials, plants and our hazardous substances are stored safely and accessed efficiently. Our storage of materials, such as any bricks, concrete, SIPS panels, timber, windows, will be stored in a designated material storage area to the west of the site, identified here. Heavy materials and concrete blocks, pallets of bricks, bags of gravel will be placed on firm level ground with adequate load bearing capacity. Pallets will be stacked according to manufacturer's guidelines and not stacked excessively high to prevent collapse or instability. This will reduce the risk of materials falling and injuring workers or becoming damaged. Weather sensitive materials such as plasterboards, insulation, timber will be stored in covered areas or inside storage containers, again located in our material storage zone to prevent water damage and deterioration and effects from pests. These materials will also be located close to the working area, which we can see in the centre of the site, to reduce any type of manual handling or moving by moving by machinery. These arrangements are justified because correct storage protects materials from damage, reduces handling, and ensures resources remain usable throughout the programme. Storage of plant and machinery and tools will be completed in our machinery and plant zone located here towards the entrance of the site. This is where machinery such as excavators, dumpers, telehandlers, and other tools will be stored in this designated parking zone, as far away from our pedestrian walkways and welfare areas, which we can see here. And this is a part of the site that has good ground conditions, which is capable of supporting the weight of the machinery. When not in use, the plant will be parked with attachments lowered to the ground, brakes engaged to prevent movement, keys will be removed and stored securely, and where possible, all immobilization systems or tracking devices will be used to prevent and deter theft or unauthorized operation. Fuel storage associated with the plant will be placed in bundled containers located here in the COSH storage, which is far away from drainage systems and far away from our domestic neighbours. This again will be covered more in the safe storage, in the health and safety section when we talk about safe storage. These arrangements are justified because plants and machinery pose significant safety risks if incorrectly stored or accessed by unauthorised persons. Designated storage areas reduce collision risks and improve site organisation. Storage of consumables and equipment. Consumables such as fixings, sealants, adhesives, PPE and small tools will be secured in secure site containers or tool stores located here in the machinery zone or within the material zone, depending on what they are. Valuable hand tools and electrical equipment will be locked away when not in use to prevent theft, which can be a common issue on construction sites. And items that are frequently used will be organised and stored neatly to prevent clutter in work areas, reducing trip hazards and improving productivity. Flammable consumables such as fuels or solvents will be stored in approved fire-resistant containers in our COSH storage area and kept away from ignition sources such as the plant zone or material zone. These storage measures are justified because they protect valuable equipment, prevent fire hazards and maintain an organised working environment. So overall, our safe storage arrangements for material, plant, consumables, hazardous substances such as COSH substances will help maintain a safe, organised and efficient construction site. All construction paperwork, keys, signing and compliance paperwork will be held and stored in the site office. So by having these designated storage areas and controlling access to hazardous materials, the site can reduce accidents, prevent damage and ensure the project progresses smoothly throughout its life cycle. When we are looking at our safety and welfare considerations, we can see that they must be carefully planned before construction work begins to protect the workforce, the public and the environment. These provisions are essential to ensure the site operates safely and efficiently throughout the 10-week project and comply with guidance from the Health and Safety Executive and legislation, particularly the CDM Regulations 2015. As we can see from our key statistics, the key area of accidents for all workers, particularly in construction, is fall from height, struck by a moving vehicle or a moving object, trapped by something collapsing or overturning, and contact with moving machinery. All of these are considerations within our project, so we must address these appropriately. For example, when working at height, it's one of the leading causes of serious injury and death in construction. Therefore, strict controls must be implemented wherever work is carried out where there is a risk to where a fall could occur that could cause injury. To manage this risk, safe access systems such as scaffolding, mobile towers, podium steps will be provided depending on the task being performed. All scaffolding must be erected by competent people and inspected regularly, including things such as scaff tags, to ensure it remains stable and compliant with regulations. Edge protections, guardrails, and toe boards will be installed, particularly when it comes to the completion of the building envelope and superstructure. And where appropriate, fall prevention systems such as harnesses may also be used. These measures are clearly justified because preventing falls significantly reduces the likelihood of serious injury, and providing safe access equipment such as MUPs that we can see here also improves productivity and allows trades to complete tasks efficiently while maintaining compliance with working at height regulations. All MUP operators will be checked to ensure they have the correct IPAF qualifications before being allowed to operate a mobile elevated work platform. As being hit by a moving object or a piece of machinery, again, is one of the main causes of accidents. It is essential that we have appropriate movement areas for both plant and pedestrians. So construction plants such as excavators, dumpers, telehandlers, they present a significant safety risk due to their size and limited visibility. To control these risks, the site layout will include designated plant routes, as you can see highlighted here by the orange arrows, following the existing path that exists on the site to circumnavigate the restaurant footprint, following a one-way route in and out of the site. This will help to reduce reversing movements, which are a common cause of accidents, or turning. Banksmen and trained spotters will be used to guide vehicle movements during deliveries and lifting operations to ensure safe manoeuvring in restricted spaces. These arrangements are clearly justified because controlling plant movement significantly reduces collision risks and improves overall site organisation and safety. To complement this, we have our pedestrian walkways. So the pedestrian routes are highlighted by the blue line that we can see circling the site. It sticks on the outside of the plant movement, on the site of the site office and welfare facilities, and you can see it highlights or it accesses the materials, the cost storage, the waste recycling, the plant zone, and the machinery zone. There are some key crossing areas, for example, from the welfare facilities to the building, the main building area, from the materials area to the main building area, to the south to the main building area, and from the waste and recycling to the main building area. The key areas the key reasons for this are to allow for multiple routes for emergency exits in case of emergency, but also to allow people to move freely on the site, but in controlled crossing areas. Pedestrian crossing will not be permitted outside of these crossing points. These walkways will be clearly marked, and where possible will be segregated from plant routes using barriers or fencing. Adequate lighting will also be provided, particularly in early mornings or evenings, to increase visibility. All pedestrians will be required to wear high-vis safety clothing, again, to increase their visibility. So maintaining these dedicated pedestrian walkways is clearly justified because it reduces the risk of workers entering hazardous areas or hopefully coming into contact with moving machinery or vehicles. Welfare considerations. Adequate welfare facilities must be provided from the first day of construction to maintain the health and well-being of workers. These are located here, that we can see clearly on their site plan, close next to the site office and close to the entrance and egress of the site. This allows workers to enter the welfare facilities easily when entering the site, to change out of soiled clothes before exiting the site, and to store PPE safely in these areas. These facilities will include toilets, hand washing stations with hot and cold water, drinking water, rest areas, and changing or drying rooms where necessary. These welfare units are easily accessible areas and separated from active construction zones as much as possible to reduce exposure to noise and dust. You can see that being that the welfare facilities are far away from the waste recycling, cost storage, and plant area. This is justified because it helps to maintain hygiene and prevents illness and supports worker well-being, which we know mental health, or poor mental health, is a key problem in the construction industry. Having these good welfare facilities also helps to improve morale and productivity and ensure the workers can perform their duties safely throughout the project. As part of this, we will be implementing pollution control, which is highlighted here. So construction activities, as we know, can generate environmental impacts such as dust, noise, contamination, runoff, and fuel spills. To minimise these risks, pollution control measures will include dust suppression, as we can see highlighted, using water sprays, proper storage of fuels and chemicals, and bunded fuel tanks to prevent leakage. There'll be drainage protection, such as silt fences and drain covers, as we can see highlighted here, where the municipal drains are located to prevent contamination. and contaminated water entering local drainage systems. These measures are justified because as a construction site, we must minimise our environmental impact and protect our surrounding communities and ecosystems. As we've touched on before, our cost storage is located here as far away as possible from our domestic neighbours. So our fuels, paints, solvents and adhesives will be controlled to prevent harm to workers and the environment, and all hazardous materials will be assessed and managed in accordance with KOSH regulations in clearly labelled containers within secure KOSH cabinets, as we can see in this image, in designated storage areas. Safety data sheets will be available to workers and appropriate personnel. Protective equipment will be provided when handling these substances. Spill kits will also be located nearby to deal with accidental leaks. These arrangements are justified because hazardous substances can cause serious health problems if not managed properly, so effective control measures reduce the risks and ensures legal compliance. So providing adequate controls for working at height, welfare facilities, plant movement, pedestrian access, environmental protection and hazardous substances ensures the site operates safely and responsibly, and these measures protect workers and the public while allowing construction activities to progress efficiently and in compliance with the necessary legal requirements. Another key area we must consider in this section is effective waste management. This is essential for maintaining a safe, efficient and environmentally responsible construction site. Poor waste management can increase project costs, create safety hazards and cause environmental damage. So therefore, a structured waste management plan, as we can see highlighted here, has been put in place with the idea of implementing the waste hierarchy of prevention, reduction, reuse, recycling, recover, and last is disposal. This is in line with guidance from the Environmental Agency. One of the key areas that we can manage waste effectively goes back to the beginning, which is the optimizing of use of materials and making sure our materials are used efficiently from the start of the project. This can be achieved here, as we saw early on through the project, through accurate ordering based on our drawings, schedules and quantity takeoffs and bin models, as well as using prefabricated components such as our SIPS panels that we are on this project wherever possible. When we order our materials that match design requirements, this reduces the need for cutting and trimming, which often creates unnecessary waste, which we'll avoid on this project. Optimizing materials is justified because it reduces the volume of unused or cut off materials that would otherwise become waste, which is both waste damaging to the environment and to the financial viability of the project. Waste volumes can also be carefully reduced by the planning of our construction processes and encouraging responsible behaviour on site. So to do this, we will train our workers to minimise cut-offs, reuse materials wherever possible, and avoid over-ordering by having strict procurement processes in place. Any reusable materials such as formwork, pallets, or temporary protection boards will be used multiple times during this project and on further projects. This will help to lower our disposal costs and reduces our environmental impact. And it also improves our site organisation by preventing unnecessary accumulation of waste materials. Some waste must be stored securely and efficiently on site before removal to prevent hazards and maintain a tidy working environment. This is typically achieved by using clearly labelled skips, as we can see here, highlighted in the waste and recycling area on this part of our site plan. So we'll have different containers for different waste streams, such as timber, metal, inert materials, and general waste. And these skips will be located in our waste and recycling area. And these will allow us to improve our recycling opportunities and prevent contamination between materials, which makes the life cycle of these materials easier to manage. It also helps to reduce trip hazards and maintains organisation in our environment. Any type of waste packaging will be removed from site and disposed of legally through our authorised waste carriers, ensuring that all our waste carriers are registered with the Environmental Agency and have the correct licences. Any improper disposal of waste can lead to environmental harm and potential disrepute for our project and legal penalties. So using licensed waste carriers ensures materials are processed correctly. There are some opportunities for recycling. For example, excavated soil may be used on site for landscaping or backfilling, or used on different projects for these purposes rather than being removed as waste. Metals, timber and plastics can also be separated and sent to recycling facilities or reused on site instead of landfill. This helps us to conserve our natural resources and reduce our landfill use. Security management. Security management is critical, so effective security measures help to prevent theft, vandalism and unauthorised access, while also protecting the workforce and the public. So on our construction site, it will contain valuable materials such as machinery and plant. So it could be a potential target for theft or trespass by children in the local area, or particularly from the local school. We know that it is our responsibility to prevent trespass and unauthorised access. So the first method of site security, it will be preventing unauthorised individuals from entering the construction site by installing a secure perimeter fence, as you can see illustrated by the red line that completely covers the site. There will be locked gates that will be authorised or will be operated by a security professional to allow access and egress. We will be using site hoarding such as this, so it will prevent people from looking into the site and particularly children becoming curious of what is occurring. It also makes it more difficult to climb over than a fence. Warning signage will also be placed at entrances and around the site hoardings to inform the public that the site is restricted and will contain hazards. We'll have strict access control procedures, such as signing in at the site office, which is located next to the entrance, and using identification badges to ensure only authorised workers are allowed on site. These are justified because preventing unauthorised access from members of the public will help to keep them safe from potential hazards, while also reducing the risk of theft and vandalism. Protection of our materials and plant must be, such as copper pipe. High value items such as solar panels must be protected from theft and damage. So they will be stored in our designated secure materials area. The site will be have 24-hour in-person security and 24-hour CCTV surveillance. These are justified because our material thefts can cause delays to the construction programme and increase the project costs. This will also help to keep things such as workers' personal possessions that are stored in welfare facilities safe from theft, from unauthorised access onto the site. So overall, effective site security involves preventing unauthorised access, protecting materials and equipment, safeguarding plant, and ensuring workplace safety and security. Implementing the measures that we can see here will help to protect the workforce and public and ensure the construction project runs smoothly. Moving on to section 2, the efficient running and management of the construction site project. Project planning is essential during the early stages of the construction, particularly for the groundworks and foundation phase, which is the 10 weeks phase of this project. This phase establishes the structural base for the entire building, and any errors here can significantly impact the safety cost and timeline of the overall project. So effective planning ensures that all excavation, drainage, installation, and reinforcements and concrete pours are carried out in the correct sequence within our 10-week allocated time frame. This requires coordination between labour, plant, materials, and inspections to ensure the work progresses efficiently without delays and safety risks. From an operational perspective, planning allows the project team to identify critical activities which must be completed on time in order to avoid delays. Planning also allows potential risks to be identified and mitigated. For example, if we complete site investigations, it may reveal poor ground conditions or underground services, as we've highlighted, which could influence our excavation methods and foundation design. So by identifying these issues during the planning phase, the project team can develop solutions before construction begins, such as as this underground service doesn't fall within our excavation area, it won't cause us a delay. Another important reason for project planning is to comply with our CDM regulations, as these require construction work to be properly planned from the outset, giving specific duties to people such as clients, principal designers, and principal contractors. So careful planning helps ensure that hazards such as the deep excavations, heavy plant operations, and concrete works are properly controlled. Planning is also important for managing our logistics on site, as our groundworks often require large deliveries of aggregates such as concrete and gravel, reinforcement. So without effective planning or delivery times and storage areas, congestion and delays could occur, particularly if the site has limited access or is located near residential areas such as ours. So effective project planning for the groundworks and foundation stage is justified because it reduces risks, improves coordination between our trades, and ensures compliance with safety regulations, and allows the projects to remain on schedule and in budget. Our key stakeholders and their influence requires consultation with several key stakeholders who influence the design, safety, and delivery of the project. For example, our client, in this case, is a commercial developer, is responsible for funding the project and defining the overall requirements for the restaurant build. Their influence includes approving the budgets, timelines, and design specs, and their decisions can affect the scope of our restaurant project, their procurement strategies, and our overall program. Our principal designer is responsible for managing the health and safety during the design phase. Their role is to identify and eliminate design risks before construction begins, such as hazards related to excavation, depth, or foundation design. Their influence is significant because design decisions directly affect how safely the groundworks can be carried out. Our principal contractor, another key duty holder under CDM, is responsible for managing the construction phase and coordinating all contractors working on site. They develop the construction program, a Gantt chart, which we've seen, and manage resources and ensure safety procedures are followed. So we are working currently for the principal contractor. Our principal contractor is critical because they oversee the day-to-day organisation of groundworks operations and ensure the work progresses according to plan. We also have other stakeholders, such as our structural engineer, who has designed the foundation specifically and ensures that they can safely support the loads from the superstructure. Their calculations determine foundation type, reinforcement requirements, and concrete specs. So their influence is essential because any design changes or structural concerns can affect our excavation depth, quantities, and scheduling. Our last key stakeholder that we'll consider is our local authority building control officer. These will review the design and inspect the foundations during construction to ensure compliance with building regulations. They may require inspections before concrete is poured to confirm that reinforcement and excavation depths are correct. Their influence is essential because construction cannot progress to the next stage until our LABC observations have been completed. Our construction program and resources. This is our 10-week broken down construction program that outlines the key activities required to complete the groundworks and foundations for the restaurant build within the 10-week time frame. Each stage has been scheduled in a logical sequence because many of the activities are dependent on the completion of the earlier task. The first stage is our site setup and mobilisation, which happens in week 1. This will include things such as, our first stage is site clearance and enabling. Our site setup and mobilisation has already happened previous to this. So our site clearance involves removing vegetation, stripping topsoil, and preparing our working area. This activity depends on the completion of the site setup, which is outside of this 10 weeks, because we must have plant access, waste storage, and welfare facilities before we can begin this area or this section. Our excavation for foundations and drainage and trenches begins in around weeks 4 and 5. So this activity is directly dependent on the site clearance phase because the ground must be cleared and surveyed before the excavation can begin. This is also a critical stage because it determines the depth and position of the foundations according to our structural drawings. During week 5, there we go. Yeah, reinforcement and formwork around week 7 is when our formation preparation and drainage installation will take place, followed by inspection by building control. So this stage depends on the excavation being completed to the correct levels. And the inspection is important because foundation concrete cannot be poured until excavations have been approved. So some of our key dependencies, as we've mentioned, site clearance is required before excavation. Excavation is required before inspection. Concrete curing at this stage is required before superstructure can be completed in the next program of works. And oversight preparation is required before the slab preparation. The slab preparation is required before the final concrete pour. We can see below how our 10-week construction program ties in with our costings for this 10-week period. Highlighting the specific resources in this area. Key activities and milestones. Throughout the construction of the restaurant building, several key reportable activities must be monitored and communicated to stakeholders because they significantly influence the progress of the project. These activities represent major stages within the construction program and are closely linked to project milestones. The first key reportable activity is our site mobilisation and setup, including installing our site hoarding and our welfare facilities, as we've already mentioned. This stage is important because it creates the operational environment for the project. If this is delayed, the entire construction program is affected because no physical construction work can begin. The second major reportable activity is the completion of the groundworks and foundations. As we've mentioned, this stage is significant because it allows the construction of the superstructure to begin. Delays during this stage would affect the entire construction program. The next reportable activity is the construction of the superstructure, which will in this instance include our SIPS panels framework. This phase is critical because it establishes the main structural framework of the restaurant building. Completing this on time allows the building envelope to be installed. And the last reportable activity is the installation of the building envelope and the mechanical and electrical first fix stage. This includes installing services such as electrical wiring, plumbing systems and ventilation. This stage must be carefully coordinated with the trades because service installations are required before walls and ceilings are completed. The final reportable activity is commissioning and project handover. This stage includes testing and mechanical systems, completing final inspections and ensuring that the building meets regulatory and client requirements. Successful completion of this stage marks the end of the construction program and the handover to the client. Progress is monitored across the project using several methods. As a site manager, I will regularly compare the construction program with actual site progress to identify any delays or changes to the schedule. Weekly site meetings are also held with subcontractors and project managers to review completed tasks and plan upcoming activities. Site diaries are used, which will be highlighted later on, to record daily activities and labour levels and any issues affecting the programme. Visual inspections and progress photographs are also used to confirm that construction stages have been completed according to the schedule. Communication. As the project progresses through its different stages, there are several types of information that I need to make sure are communicated clearly to the construction team and other stakeholders. Effective communication is essential to keep the project on schedule. At the start of the project, one of the most important pieces of information I'll communicate is the construction program and schedule. This will be done through our common data environment, which is Procore on this project, and will be and access will be given to the principal designer, contractor, and potentially the client if they wish to. This will include the timeline of the entire project plus the individual timelines, as we can see here, for the 10-week groundworks and foundation phase. Communicating this program ensures that when subcontractors and suppliers know when their work is scheduled, they can prepare the necessary labour, materials and equipment. Another important area of communication is design information, as we've touched on, such as our drawings and our technical specifications. This will mean that any updates to the design, if changes are made using our common data environment, this information can be distributed quickly to relevant contractors. This helps prevent mistakes on site and avoids costly rework. We'll also need to communicate resource requirements and delivery schedules, construction activities such as concrete foundation pours or drainage installation, as these rely on materials arriving at the correct time. By communicating delivery schedules to suppliers and site teams, I can ensure that materials are available when needed and the storage areas on site are organised effectively. We must also communicate any progress against the construction programme, and I'll regularly update the project team and have the client on which stages of the work have been completed and whether the project is meeting its planned milestones as highlighted in the Gantt chart. This allows the team to identify any delays and take corrective action if required. Any inspection results and quality checks will also be communicated at certain stages of the construction, such as foundation, excavations or drainage installations, as these require inspections from LABC before work can continue. Communicating these results ensures that everyone involved knows when a stage has been approved and when the next stage of work can begin. Finally, I'll communicate operational and logistical information, such as delivery times, site access routes, and coordination between trades, as this helps to maintain an organised site and reduces the risk of delays caused by poor coordination. The key stakeholders that we have touched on already include the client or developer. These need regular updates from me regarding project progress. The principal contractor and site management team require detailed information about the daily operations of the project, including labour allocation, plant usage and material deliveries. The design team, such as their architects and structural engineers, they need to be informed about any technical issues that arise during the construction, such as unexpected ground conditions or design conflicts. Subcontractors and construction workforce, as we've got here, they require clear instructions about their specific tasks, work schedules and construction methods. I'll communicate this information through site meetings, briefings and method statements so that workers understand exactly what work needs to be completed and when. Suppliers and delivery companies need to know what materials are required and the quantities needed. Providing this information ensures that materials arrive at the correct time. Local authorities and inspectors need information about specific stages of construction that require approval, and so that will be shared with them. Moving on to the last stage of our presentation, monitoring and reporting progress. We've touched on this already, so we'll go over it in a little bit more detail. As the project progresses, it's important that the progress is continuously monitored and measured to make sure we stay on track. Monitoring progress allows me to identify any delays or issues early so that corrective action can be taken before they affect the overall completion of the project. One of the main ways I will monitor progress is through site diaries on the Procore system. So each day, recording the activities on Procore that have taken place on site, including what work has been completed, how many workers were present, what plant and equipment were used, and any issues that may have affected productivity. These records help me track whether the project is progressing according to the planned schedule and provide evidence of what work has been completed at each stage of the build. Another important method I use will be visual inspections on site. I'll regularly walk around the site to observe the work that is being carried out and confirm that construction activities are progressing as planned against their as-built drawings, or against their drawings, I should say, and BIM models. Quality checks are also an important key way of monitoring progress, which I'll complete on site walkarounds. I'll also carry out health and safety checks as part of our daily management of the site, reviewing accident data, reviewing risk assessments, and making sure any changes to the site, such as changes in machinery or changes in chemical products, have the correct control measures in place. Monitoring this health and safety performance helps maintain a safe working environment. I'll also conduct regular site meetings to pass on key information. During these site meetings, we'll review what work has been completed, discuss upcoming tasks, and identify any issues that may affect the programme going forward, as well as highlighting any health and safety feedback in order to maintain safety. I'll also make changes and updates to the as-built programs, again, using the Procore system, as we can see here, to reflect the actual work that has been completed. This allows me to compare the planned schedule with the real progress on site. If there are any delays or changes to the program, they can be identified and managed effectively. All the relevant stakeholders will be reported to, as we've mentioned in the previous slides. And one of the key areas is uploading the site diary to Procore to ensure that the relevant stakeholders have got access to this, and making sure any information related to the critical path is updated on Procore also. These will include things such as progress photographs and inspection reports. Key statistics and performance indicators will also be included. So the principal designers and the client can see the progress of the site. That brings us to the end of our presentation. Hopefully you can see how we have covered the three areas: planning and organising it, the efficient running and management of the site, and the monitoring and reporting of progress. Thank you for your time.